All right, so here's a screencast for part 3. So a little summary before we get started. If we're talking about the average, right, we're talking about the secant, and so this is what you use the slope formula for. So the average gives you the average over a time, which means you're using your secant. Okay, so this is like if you're taking a little drive from LA to Las Vegas, you can say your average was 80 miles per hour. But we both know you're not going 80 miles per hour in LA, which means you have to be going faster on the 15 freeway. So the average doesn't necessarily mean you're going that amount every single time, right? Versus if I'm talking about the instantaneous, the instant velocity, the instant speed, that's when you look at your speedometer. And that's how fast you're going at that moment. So this is the tangent line, all right? When we're touching the graph at one place, we want to know the slope of the tangent at that instant, at that moment. This is your speedometer. And so this is when we use the H equation. So trying to give you a little like summary, this is really the trick that's going to be in the second quick check of this chapter. Okay, so the average rate of change. So the average rate of change of a quantity or function is the total change in y over the total change of x. All right, so delta y over delta x. Literally, y2 minus y1 over x2 minus x1. This is the baby slope equation that you learned in algebra. So the average rate of change, no surprise, we've kind of already gone over this. So velocity is the rate of change of an object. Rate of change. Now, you can have an average velocity, which is the total distance over total time. So if it is, I know this is not true, 200 miles to Las Vegas, and it takes you 2 hours, you are going 100 miles per hour. You know what? Let me switch this. 4 over 4 hours. Yeah, 50 miles per hour. It took you 4 hours to get to Vegas, and it's only 200 miles away, then your average was 50 miles per hour. But we know that's not exactly accurate, right? The whole time you weren't necessarily going 50 miles per hour. So I'll come back to this example in a later screencast. Okay, so the average is just your displacement over time. How far you traveled over your time. So this is your y2, right? Your s of t2, because s of t is our function of position. So position 2 minus position 1 is your change in position. Over your time 2 minus time 1, so this tells you how long it took you, your overall time, and this is going to be your slope. So example 3, a water balloon is propelled straight up using a launcher. The height of the balloon in feet, t seconds after its launch, can be defined by this equation here. What is the balloon's average velocity between time 1 and 2? Okay, so it gave us time 1 and 2. We're looking for the average velocity, so that's why I use V for velocity. AVG means average. So I'm taking the position of our second time minus the position of our first time. That's just y2 and y1. And then the change in time. So t2 minus t1. Okay, so my second time is 2 seconds. So I have to plug in 2 into my function. And then I'm going to subtract my first position. So final position minus start position means how far you actually traveled. So 2 minus 1 on the bottom for change in time. So let me plug in my t2. Now there's 2 ways you could do it. You could like write out this long function, or I can come down here in a little separate sheet, little separate line, and let me just plug in and see what the number would be. Times 2 minus 16 times 2 squared. Here's s of 1, 5 plus 65 times 1 minus 16 times 1 squared. Okay, this bottom one's easy. 5 plus 65 is 70. Minus 16 is going to be, wait, did I do it wrong? No. 2, no, we're good. Looking at the wrong line. Okay, so this is 54, 70, 60, yeah, 54, and this first one is going to be 71. Okay, so we have 71 minus 54 over 1, so that's going to be 17 feet per second. So they gave us units, so you must write the units. And we're looking for velocity. Velocity is always a distance over a time. So feet over seconds would be the correct unit. So this homework, there's 4 different homework assignments on this. Check your lesson plan to see when they're due. Come to class and let me know if there's any questions.